In 12.2, the first thing we're going to learn about is angles in standard position. So the first thing you want to do is make your x and y axis. So we know that an angle requires two lines, or two line segments, or in this case, two rays. So there are two sides for an angle. Now, in standard position, you start the angle with the positive x-axis. So if you want to do an angle in standard position, you have to start here. So that has to be one of your sides. That's called the initial side. And then the other side, which is called the terminal side, is determined by whatever the angle is. Alright, so if the angle is positive, you go counterclockwise. So if it's positive, you go this way. I've gone 90, then 180, now 270. Now I have to go 20 more and stop there. Alright, so that angle is in standard position. This is your initial side here, and this is the terminal side. Alright, so number 1 is also positive. So we start with the positive x-axis as our initial side. Because it's positive, we go counterclockwise. I've got 90, 180, 30 more. You need this spiral arrow so it shows which direction you went. Because if I didn't have that, then this could have been negative 150 degrees. Alright, and I need to indicate this is 210 degrees. In the example, I didn't indicate this was 290 degrees. Okay, number 2 is negative. So we still start with the positive x-axis. That's our initial side. And because it's negative, we go clockwise. So 135, this is negative 90. I need to go 45 more, so halfway. And that's negative 135, negative 135 degrees, and I need the arrow on the spiral so we know which way we went. Alright, number 3 is positive, and it's bigger than 360 degrees. So again, initial side is where it always is. We rotate. So I go 360 degrees, and then I go 40 more to make 400. And now I draw the terminal side, and I label how far we went. Alright, for the next set of problems, we're finding coterminal angles. So what does this word mean? Well, co usually means same, and terminal means end. So these are angles that end in the same spot. Alright, so think about running on a track. No matter where you start on the track, if you run exactly one lap, you'll end up in the same spot. And if you run backwards one lap, you end up where you started. So the way to find a coterminal angle, you add one lap or 360 degrees. We know a circle is 360 degrees, so if you go around 360 degrees, you will end up in the same spot. So for number 4, I'm going to take 65 degrees, and I'm going to add 360 degrees. And if I do that, I know I end up in the same exact spot on the circle, which means it is coterminal. Right, if I want to find a negative angle, I start at 65 degrees, but then I go backwards one lap. So that'll be negative 295 degrees. For number 5, I'm going to do the same thing. Take the angle we're given, add 360 degrees. So 360 minus 75 is 285. Then we're going to take negative 75 degrees and subtract 360 degrees. That'll be negative 435 degrees. Right, so this doesn't always work, as you'll see on number 6. You can't just always add 360 and subtract 360. Right, so if I add 360 degrees here, I get 780 degrees, which could be my positive answer. But if you take 420 and subtract 360, you get 60, which is still positive. So what I'm going to do is I'm going to subtract 360 times 2. So if you subtract 360 from 420, you get 60, which is still positive, so you have to do it again. So if we subtract 360 twice, then we get a negative answer. So these problems have infinitely many possible correct answers. We didn't have to use 780. I could have used 60 degrees instead. So add 360 times an integer and you'll have a coterminal angle, and subtract 360 times an integer. So you could add 360 as many times as you want, or you could subtract 360 as many times as you want, and you'll end up in the same spot. Alright, so we're aware that a whole circle is 360 degrees. That's in degrees. There's another unit of measure known as radians. A whole circle is also 2 pi radians. And if you divide both of these numbers by 2, half a circle is 180 degrees, which is equivalent to pi radians. And we're going to use this to convert back and forth between degrees and radians. So on the front of the notes, we just learned that pi radians is equal to 180 degrees. So this is going to be like dimensional analysis. Number 7 is in degrees. We want it to turn that into radians. So we're going to multiply. And we're already in degrees, so we want degrees to cancel out. So we have to put degrees on the bottom and what it's equal to on top. And I don't have to write the word radians because seeing the pi, you already know it's in radians. Alright, so we just have to reduce 140 over 180 is the same as 14 over 18. 14 over 18 is 7/9 pi. And that's in radians, and we know that because of the pi. Alright, number 8 is also in degrees. So we put degrees on the bottom. 180 degrees is equal to pi. Alright, so this is the same as negative 26 over 18, divide by 2, we get negative 13. Divide 18 by 2, we get 9. So negative 13/9 pi. Alright, number 9 is in radians. So when we multiply, we want the radians to cancel out. So those go on the bottom, and the degrees go on top. So the pi's cancel out, 180 divided by 5 is 36. 36 times negative 3 is negative 108. And this is now in degrees. So to go from degrees to radians, put the degrees on the bottom. Radians go on top. Degrees cancel out. Looks like they're both divisible by 5. They're also both divisible by 15. 75 divided by 15 is 5. So we're going to have negative 5. 180 divided by 15 is 12. Number 11 is in radians, so we put radians on the bottom. Pi's cancel out. 180 divided by 6 is 30. 30 times 7 is 210 degrees. Number 12, degrees goes on the bottom. Radians go on top. Alright, so cross out the zeros on the end. 38 over 18, we can divide by 2. 19 over 9 pi. Alright, now we're going to learn about arc length. So you learned in geometry that the circumference of a circle equals 2 pi times the radius. Alright, so what if you only wanted part of a circle, which is the arc length? So if you wanted the length of an arc, but not the whole way around a circle, what you did was you would take this 2 pi r and you multiplied it by whatever fraction of the circle you had. So let's say you had a quarter of the circle. Then you multiplied by 90 degrees over 360 degrees. So this is what you would do if you knew the central angle in degrees. But what if you know the central angle in radians? So thinking about it logically, the whole circle is 2 pi r. And let's say we have half a circle. So half a circle is pi. The whole circle is 2 pi. Notice the 2 pi from the whole circle and the 2 pi in the formula cancel out, and it's just r times your angle. So the equation for arc length is r times the angle in radians. In this example, the angle was pi. So the formula for arc length, S equals r times the angle in radians. Alright, so for number 13, all we do is, and I'm not sure why they use S for arc length. So S equals, we take the radius times the angle in radians. It says round to the nearest tenth, so we want to use a calculator. So we get 8.4, and that seems reasonable. That whole circle would be, what's 4 times 2 pi? Would be 8 pi. 8 pi would be more than 24. Looks like we only want to go 1/3 of the way around. So yeah, 8.4 seems reasonable. Alright, for number 14, we take the radius, which is 3. Multiply that by the angle in radians. Using a calculator, we get 10.99557, so 11.0. Alright, for 15, S equals r times the angle. The 3's cancel out. 4 times pi, rounded to the nearest tenth. is 12.6. Alright, I'm going to use this time to introduce the unit circle to you guys. So the unit circle has three things. It has coordinates, it has the angles in degrees, and the angles in radians. So let's start with the angles in degrees. We just learned that the initial side is where it starts. That's the positive x-axis. So that is 0 degrees unless you go around one revolution, then it's 360 degrees. Right. Other ones that are easy to fill out, we know a right angle is 90 degrees. Half a circle is 180 degrees. 3/4 of a circle is 270 degrees. All right, let's do the middle spots now. So half of 90 is 45. In quadrant 2, 90 plus 45 is 135. 180 plus 45 gives us 225. 270 plus 45 is 315. Alright, the other spots are 30 degrees and 60 degrees away from the end. So take 90, add 30, you get 120. Take 90 and add 60, you get 150. Take 180 and add 30, you get 210. Take 180 and add 60, you get 240. 270 plus 30 is 300. 270 plus 60 is 330. Alright, now let's convert all those angles to radians. So 0 is here, which is also the same as 2 pi. Alright, so the key thing to remember is pi equals 180. So I'll put that one first. Pi and 180 are the same. So if pi is 180, well, what's 90? 180 divided by 2 is 90. So that's the same as pi divided by 2. What about 60? 180 divided by 3 is 60. So 60 is pi over 3. 30 is 180 divided by 6. So this is pi over 6. 180 divided by 4 is 45, so 45 degrees is pi over 4. Alright, so there are a lot of different techniques that people use. I like to count by 30s and 60s. So looking at 30 degrees, we know that's pi over 6. So I'm going to count by 30s, but in radians. So follow with me. Pi over 6, 2 pi over 6, reduced. 3 pi over 6 reduced, so then this one has to be 4 pi over 6, but reduced. And this one is 5 pi over 6. This is 6 pi over 6 reduced. So then over here we have 7 pi over 6. 240 will be 8 pi over 6, but I can reduce that. This is 9 pi over 6, reduced. 10 pi over 6, can reduce. And then over here we have 11 pi over 6. So all I did was count by 30s, which is pi over 6, and I reduced each one. Alright, now let's try counting by 45s, which is pi over 4. Alright, so we have pi over 4, 2 pi over 4, and this middle one here will be 3 pi over 4, 4 pi over 4, and then this one is 5 pi over 4, 6 pi over 4 is this guy, and over here is 7 pi over 4. Alright, so that's my quick way of converting degrees to radians. You guys learned another way. It's multiply by pi over 180. Alright, so again, this is called the unit circle. It's called a unit circle because it has a radius of 1. Alright, so the origin is the center of the circle. Remember, the circle has radius 1, so the coordinates here are 1, 0. The circle has radius 1 and is centered at the origin, so the top of the circle is 0, 1. On the left side of the circle, that's -1, 0. And the bottom is 0, -1. Alright, now recall special right triangles from 12.1. So, if you're trying to figure out the other coordinates, envision a triangle, special right triangle. We know that this circle has radius 1, so if I draw a 1 on the hypotenuse, this is a 30, 60, 90 triangle. So this side, that would be my y coordinate. Well, what's the short side of a 30, 60, 90 triangle? It has ratios 1, rad 3, and 2. But, so 1, rad 3, 2. But we already know that the hypotenuse is 1. So all of these have to be cut in half. So this is 1/2. The long leg is rad 3 over 2. Alright, over here, this is a 30, 60, 90 triangle also. But that one has a longer y coordinate. So rad 3 over 2 goes here. 1/2 is here. Alright, we also learned about a special right triangle that's a 45, 45, 90. For 45, 45, 90 triangles, we know that both legs are the same length. And if the hypotenuse is 1, how do we find the other sides? Well, we divide by rad 2. 1 divided by rad 2, if you rationalize, is rad 2 over 2. Alright, so some key lengths that you need to remember are 1/2, rad 2 over 2, and rad 3 over 2. This number is always used for the middle spots. And then 1/2 and rad 3 over 2 always go together. Alright, so looking at 120 degrees. So you'll notice the x coordinate, the x distance, is a lot shorter than the y distance. So the x gets this short distance of 1/2. But because we're in quadrant 2, the x is negative and the y is positive. Right, at 150, the x distance is a lot longer, so they get the rad 3 over 2, and it's negative. The y isn't as far, so it gets 1/2. The middle spots always use rad 2 over 2. And in quadrant 2, the x's have to be negative. Again, the middle spots always use rad 2 over 2. When you're in quadrant 3, both of these are negative. So middle spots, rad 2 over 2, rad 2 over 2. In quadrant 4, only the y is negative. Alright, for 210, what's longer for 210? Is 210 further in the x direction or further in the y direction? Looks like the x distance was a lot longer. So that gets rad 3 over 2. The y distance was short, that's 1/2. These are both negative. Alright, looking at 240, the x distance is short, the y distance is long, so the x gets the 1/2. the y gets the rad 3 over 2. These are both negative in quadrant 2. Alright, 2 more coordinates. So looking at 300, the x distance is short, the y distance is long. So the y gets the long number, rad 3 over 2. The x gets the short number. What's negative? Y is negative in quadrant 4. Right. And then for the last one, 330, that's a far x distance, but a short y distance. So far for the x is rad 3 over 2, 1/2 for the y. Alright, what is this used for? Well, if you're trying to do trigonometry, the x is going to represent your cosine, and the y is going to represent your sine. So for example, if I want to know cosine of 150, well, cosine of 150 is the x-coordinate, negative rad 3 over 2. Sine of 150 is the y-coordinate, 1/2. If you want tangent, you take sine and you divide by cosine. So tangent is y divided by x. So tangent of 45 degrees would be 1, because rad 2 over 2 divided by rad 2 over 2 is 1. Tangent of 315 degrees would be negative 1. So I would say mastering the unit circle is probably the most important skill that you could carry on to math analysis. And knowing the unit circle now will help you do the rest of the chapter a lot quicker. You don't want to be drawing triangles for every single problem. If you could just know how to do the unit circle quickly, that'll save you a lot of time. Alright, that's it for this lesson.